This video explores the Shimadzu AGSX series, a precision universal testing system. We will examine its architecture, software integration, and its application in high-strength alloy compression. Modern materials require unprecedented strain control. From iron and steel to plastics, resins, and ceramics, each material demands specific, highly accurate testing parameters to ensure reliable data. The Autograph AGSX provides this control through high-precision force accuracy, high-speed sampling at 1000 Hz, and intelligent real-time auto-tuning of control parameters. Engineering the core of the AGSX involves an expanded testing range, direct strain control with a precision ball screw drive, and automated calibration for instant load cell recognition. Safety and usability are built into the design, featuring one-touch stroke limiters, an interlock safety cover, dual emergency switches, and a jog controller for fine positioning. The Trapezium X software ecosystem supports the entire testing process, from visual setup and execution modes to real-time analysis and automated report generation. A study by the Swiss Federal Laboratories, EMPA, demonstrates the AGSX in action. Researchers used it for compressive testing of ductile, high-strength AISI 316L stainless steel. Compressive testing is complex, prone to issues like lateral drift, buckling, and barreling. For ductile metals, precision compression data is essential, as yield properties differ from tensile proxies. To avoid measurement errors caused by material indentation into bearing blocks, the solution involves localized strain measurement directly on the specimen. The ideal test rig architecture incorporates a local clip-on gauge, hardened steel cones to increase working space, and a spherical culotte to ensure perfect parallelism. Finite element modeling confirms that while friction causes sample barreling, it does not significantly corrupt strain data when measured locally at the center of the specimen. A hybrid workflow uses the clip-on gauge for sensitive elastic data up to 4% strain, then automatically switches to crossbar displacement for the plasticity phase. Data shows that while tension and compression curves track together in the elastic domain, they diverge post-yielding, underscoring the necessity for specific compression testing. The AGSX series includes various tabletop and floor-type configurations to meet diverse needs, all maintaining a guaranteed 0.5% force accuracy and 1000 Hz sampling. By providing this level of precision and control, the Shimadzu AGSX series empowers researchers to engineer the future with absolute certainty.